Ever pondered on the mechanics of support vector machines? Today, we're going to unravel the mystery behind this fascinating machine learning model, popularly known as SVM. SVM is a supervised learning model, widely used for classification and regression analysis. But what sets it apart from other models? Let's delve deeper into the world of SVM. SVM works by finding the hyperplane that best divides the dataset into classes. Picture a space with scattered points of two different colors. Now imagine a flat surface that separates these points based on their colors. This surface, my friends, is our hyperplane. But of course, there could be multiple hyperplanes capable of achieving this task. So how does SVM choose the best one? It does so by selecting the hyperplane that maintains the maximum margin from both classes. This margin, also known as the street, is the distance between the hyperplane and the closest data points from each class, which we call support vectors. Now, you might wonder what happens if the data isn't linearly separable. Well, SVM has a trick up its sleeve. It uses a technique called the kernel trick. This technique transforms the data into a higher dimension where it can be linearly separated. It's like lifting a jumbled set of points into a 3D space where a plane can easily separate them. But SVM isn't just about finding the best hyperplane and maximizing margins. It also deals with a concept called regularization. Regularization helps prevent overfitting, ensuring that the model performs well, not just on the training data, but also on unseen data. It does this by controlling the trade-off between achieving maximum margin and minimizing misclassification. To summarize, support vector machines work by finding the best separating hyperplane, maximizing the margin from both classes, and using the kernel trick to handle nonlinear data. They also incorporate regularization to prevent overfitting. Remember, SVM is like a skilled artist, carefully crafting the best line, or in some cases a curve, to separate the data. It's a delicate balance of separation, dimensionality, and regularization. Understanding SVM is a leap towards mastering the art and science of machine learning. And there you have it, a quick journey through the intriguing world of support vector machines. Hopefully, this has shed some light on the inner workings of this powerful machine learning tool. Keep exploring, and who knows what other fascinating discoveries you'll make in the realm of data science.